And so I thank Grace Kennedy Foundation really seriously for the opportunity they have provided for me to offer this tribute in this way today. As you have heard, my children are also here today, Amanda, Melanie, and William. And so I want to say something to them. No pressure. It is not a family tradition that we are starting here. And so I have no expectations about what 22 years from now will bring. But let me also quickly pay tribute to my wife as well and the other family members, especially those who have supported me during this whole process. And thank also the Climate Studies Group, Mona, of the University of the West Indies. And in particular, Miss Felicia White, who is sitting somewhere in the back there, for assistance received in preparing this lecture. But I'm not going to keep us going for long, so let's get to the matter at hand. Why does climate demand change? This afternoon, really all that I want to do is offer you what I am going to call, let's just get this. What I'm going to do is offer you what I'm going to call a physicist's contextual reading of the state of the climate with respect to, state of the Caribbean with respect to climate. So it's a contextual reading because all I'm really going to do is offer you 3 observations, or just some observations about the state of the Caribbean with respect to climate. But it's a physicist's contextual reading because all good physicists love a good equation. And so I'm going to offer you an equation. And I'm going to be bold enough to name it the Taylor's equation of state of the Caribbean with respect to climate. Well, my equation is going to be very simple. It's going to look like this. A plus B plus C equals D. And that's all I want to do, offer you this equation. D is going to be my reading from observations about what the desired state of the Caribbean should be with respect to climate. And then A, B, and C are going to be my reading of what the current state of the Caribbean is with respect to climate. So all I want to do in this lecture is offer you what A, B, C, and D are. D being the desired state, A, B, C being the current state. And in fact, I want to get along with it very quickly by telling you immediately and off the bat what D is. And I get D from a very landmark statement that came out of the SIDS conference, the Small Island Developing States Conference that was held in Samoa recently, well in November of last year. And they suggested climate change represents the gravest threat to survival and viability of small island states. Well, if it is true that climate change represents the gravest threat to survival and viability, and in my mind, survival plus viability equals sustainability, then you can see that variable D in my equation is sustainability. And so all I want to do then is offer you 3 observations about what variable A and B and C must be. And then leave it up to you to decide whether A plus B plus C equals sustainability. All right, but before I can offer you A, B, and C, I think I need to set a little bit of a background. Forgive me, I'm a scientist, so we're going to talk a little science. So here is a background. I need to set up, of course, first of all, what do we mean when we talk about climate? When we talk about climate, we have to make a little bit of a distinction. We make a distinction between climate variability and climate change. By variability, we talk about the short-term changes in climate. So we talk about changes that could happen this year, but not be the same next year. Or we talk about changes in groups of years, or even changes on decadal scales. So if I were to plot what the mean temperature of the Earth were to look like over the last 150 years, you don't have to worry what it looks like, but you can see that the variability in it. The variability in that plot would be represented by the squiggles in the plot, squiggles being a great scientific term. The climate change, however, is looking on the long-term changes in the climate. And in that plot, climate change would be represented by the long-term trend that we have seen over the last 100 years. So the straight line. So we make this distinction between variability, short-term changes, and change, which is a long-term change. What causes climate to change? Well, a number of things. When we think about variability or the short-term change, climate change is associated with what we call some global phenomenon, and they usually have some known cycle to it. So many of us have heard about the El Nino phenomenon. And an El Nino is nothing more than a warming of the equatorial Pacific. So if you look in the plot, you can see that big red blob over the ocean in the Pacific, and an El Nino is a warming. And that warming normally occurs every 3 to 7 years. The thing about it is that when it warms, it normally dries out the Caribbean. And so if you look on the plot right beside it, you will notice that every couple of years we go into drought. So the variability is driven by the natural cycle of the El Nino. Every so many years we get dry due to the El Nino. Climate change, on the other hand, has a number of things that can cause it to change. Climate can be changed due to natural variations. Climate can change due to volcanic eruptions. And the one that we want to deal with here today is a climate that is changing due to human activity. Now, human activity like burning of fossil fuels, so when we burn oil or gas or coal for electricity or for industry or for transportation, it contributes to climate change. Or when we cut down trees for deforestation is a contribution to climate change. What happens is that human activity allows for the releasing of carbon dioxide into the atmosphere. And carbon dioxide now enhances what is known as the greenhouse effect. And the greenhouse effect is nothing more than literally the atmosphere acting like a greenhouse. So it allows the sun's rays in, they heat up the earth, and then the atmosphere traps that heat. And part of the thing that causes the atmosphere to trap the heat is, of course, carbon dioxide. So human activity releases carbon dioxide. It contributes to the greenhouse effect. And the result is that as the carbon dioxide increases, which is the blue line, you can see that the temperatures, which is the red line, also increase. And so climate change is directly related to human beings' release of carbon dioxide. Well, therefore, one of the manifestations of climate change is clearly warmer temperatures, and the warming is everywhere, as you can see in the diagram for the world. But it's not only warmer temperatures, but when the temperatures warm, then the rainfall becomes variable. And so everywhere that is green, the rainfall is getting wetter, and everywhere that is brown, it is getting drier. And not only does the rain become variable, but we get stronger extremes. And so if we look on hurricane intensity, you can see the upward slope of climate change in the hurricane intensity. And then if you look on sea ice, you can see that it is declining. And then of course, if you look on sea level rise, you can see the upward trend of climate change in it. So when you put all of this together, these are the manifestations of climate change. What then is the context that I am reading for the Caribbean? I'm reading this context. We live in a context of variability and climate change, where climate change is a distinct changes in measures of climate, things like rainfall, temperature, wind speed, but those lasting for long periods of time due to human action. In the Caribbean, our challenge is to live with the variability while contending with the change. So it's this context then that I want to offer you my reading and my 3 observations. I want to offer 3 observations about the state of the Caribbean with respect to climate. And as I told you, my observations will come in the form of A plus B plus C equal sustainability. Let's go on, observation number 1. What then is observation number 1? It's this: the Caribbean possesses an inherent sensitivity to climate. What does that mean? In my equation of state, variable A is sensitivity. It turns out that Caribbean countries, their economies, the daily ordering of the life of their people and their natural systems are extremely sensitive to variations in climate on whatever time scales they occur. How do we come by this? A couple of reasons. One, our geographic location. When we look at our geographic location, we are strategically located in the Atlantic, but with close proximity to the Pacific. What does this do? This sets up a very familiar pattern or seasonality in our rainfall and temperature. So if you look on the diagram and the bars represent the rainfall, you see the pattern that you and I are used to. So you can see that January, February, March, we are dry. And so we expect the drying that we have now. But by the time we hit May, you can see that the rainfall pattern has gone up. And we stay wet from May to November with a brief drying in the middle in July. And that characteristic bimodal pattern, or that characteristic M-shaped pattern, becomes a pattern around which we build life. And if you look at the little line at the top, that's the temperatures. And we don't vary much in temperatures, but you can see that by the time we hit the middle of the year, we are slightly warmer. What happens with this? We can see this pattern in various indicators of life in the Caribbean region. And so, if we look, for example, on how much water we can get from our rivers. For example, how much water can we get from the Great River? Can you see the M-shaped pattern of the rainfall in the stream flow of the rivers? And if, for example, you look on how many reports of fire were made at the Clarendon Fire Station, and we flip it upside down, can you see the M-shaped pattern of the rainfall in the fire reports? And then if, for example, you look at energy consumption, generation and sales, it's not the rainfall M-shaped pattern that you see now, but you see the pattern of the temperatures where it peaks in the middle of July. And we build our life around this pattern. So you can see it then also in the agriculture pattern, because we reap and plant around this pattern. We even offer recreation around this pattern. We build our life around this pattern. So climate then becomes entrenched in the general ordering of Caribbean life, so much so to the extent that there's a dependence on the regularity and familiarity of this annual cycle to provide us with a sense of what is normal. So this pattern contributes to our sensitivity. But it's not the only thing that contributes to our sensitivity. Turns out our geographic characteristics also. In the Caribbean region, we're either all low-lying or volcanic, with mountainous interiors and very short coastlines, or we possess some combination of hilly interiors and limited coastal plains, and you see it spelled out for Jamaica right there. What does this mean? This means that the combination of size and topography severely restricts the available land for development and forces the dependent on either narrow coastal areas or very, very steep hillsides for the location of major cities, infrastructure, large-scale agricultural plots, and economic and industrial zones. It should not surprise you that in that previous plot, 10 of our 13 capitals are located on the coast. 50% of the Caribbean lives within 1.5 kilometers of the coast, which means that they're automatically sensitive to climate variations. And if you are not among the 50% in the coast, the other 50% therefore lives on the hills. But then when the rain comes too heavily, you also are susceptible. So our geographic characteristics make us sensitive. It's not just our geographic location and our geographic characteristics, but our economic activities. We rely on economic activities which in their present form are very dependent on favorable climatic conditions and natural resources. So we only need to think about agriculture and tourism, and the fact that combined they contribute to about 14 or 15% of the GDP for Jamaica in 2012 and 2013, or approximately nearly 50% of the labor force in the Caribbean. Both things together help account for the strong link between livelihoods and climate in the Caribbean. And then if you don't want to take the fact that geographic location makes us sensitive, or geographic characteristics makes us sensitive, or economic activities, then you only need to think about water. For in the Caribbean, rainfall is king. It turns out that we have this overwhelming dependence on surface and groundwater, which means we have a very strong dependence on rainfall. And so when you put all of these things together, you can see that we have a sensitivity. Our context is one of being sensitive to climate. And a very interesting sensitivity, if I might also add, because the sensitivity is an embedded sensitivity or an entrenched sensitivity. Because it turns out that even if we could diversify economic activities to get rid of that sensitivity, we can't change geographic location or geographic characteristics. So the sensitivity is embedded in us. It's not only embedded, but it's also pervasive through either direct or indirect influence.